Well, recall that the absolute value function is a v-shaped curve whose vertex is at the origin. And so this function is just a transformation of that 5/2 to the right. And this is a horizontal compression factor 1/2. So it's going to be steeper. Anyway, this means the vertex is just 5/2 to the right, like this. In other words, you can always find where the vertex is by setting the expression inside the absolute values equal to 0. All right, so it didn't move up or down, so just 5/2 to the right. All right, so the area between this curve and the x-axis from 0 to 5 is just the area of these two triangles. So two triangles gives us the area, and we didn't even need to do any calculus. But if you want to do calculus, we actually have a piecewise defined function. We've got a negative slope for this straight line and a positive slope for this one. Remember that when x is less than 5/2, this expression will be negative, and the absolute value function will take the opposite of it, making it positive. However, to the right of 5/2, this expression will be positive, and the absolute value symbols will have no effect. In other words, the function is equal to just that straight line with the positive slope of 2x minus 5. You can see it's crossing the y-axis at -5. When x is greater than 5/2, but it's equal to, well, when we have x values left of 5/2, then this expression is negative, and the absolute value will take the opposite of it. And we can let either one of these include 5/2. It won't make a difference. It's 0 right there. All right, so if we wanted to do this problem with calculus, although I don't know why you'd want to when we can just use geometry to find the definite integral, but with calculus, it would look like this. Does that make sense? From 0 to 5/2, it's the opposite of 2x minus 5. And from 5/2 to 5, it's 2x minus 5. Doing all the work and all the substitutions, we get the same answer. So this was a good practice of basic integration if you did all the work, but it's really a great example showing that we should think of these problems geometrically when it suits us. And it definitely suited us to think of this problem geometrically. It's much easier, simpler, and more elegant than doing all this work.